So that's question number 1. Okay. Oh, is that 2? That's a 2. My bad. Start from there. Go. All right, question number 1. I'm sure you did that. This will take some time just because of, It's a 55 kilogram hyper. All you got to find is the change in potential energy, right? Change in potential energy. What's the formula for change in potential energy? Does this mass change? Does G change? The only thing that changes is the height, isn't it? That's why I wrote it as mg times delta H. What do you mean by delta H? Change in height. What's the mass? 55 times 9.8 times the change in height is 3,300. Take away 1,600. Is that clear?
Yes.
And so when you multiply those numbers, I can speed it up a little bit, but I have kept it slow. Is this the number that you get? 9.163 times 10 to the, is it 10 to the 5 that you got? Yes, 10 to the 5 joules. Is that too slow? It's a little bit. Okay, I'll speed it up a little bit more. Okay. Now the second question says, what's the minimum work required? Minimum work, same. Because if it is if that is the change in potential energy, he has to do that much work at least, isn't it? So it'll be the same. Now go to C. What does it say? Can the actual work done be more than this? The answer is yes. But explain. Because he has to do work against the air resistance, doesn't it? Did we consider the air resistance? Did we consider friction? Come on, guys. We neglected air resistance, we neglected friction, and we only considered the work against gravity. Do you understand that? So, in real life, he would have to do more work than this. Question number 2. Like I said, F is equal to K times delta X, isn't it? Okay. And what's the force? Don't you remember that force is mg? So if you have 2.5 kilograms there, it's going to be 2.5 times 9.8 divided by, I forgot to put the number for K, but I'll put it up. What's K? 53. I'm going to put it up. I promise you.
That's like 4 points.
Okay, so delta X is, see, I erased that. You could even see that. And put in the number for K, which is 53. So it's 0.4623 meter, which is 46.23 centimeter. Why did I have to change it to centimeters? Because the original was given as 15 centimeter. Now I need to add that much to this, isn't it? Because isn't that how much it went down? Delta X is how much it stretched. So to get the new mark, I need to add 46.23 with 15, and I end up with 61.23 centimeter. Is that right? Oh my goodness. Why should this happen to me? Can see this? Searching. Can't find it. This is gonna go mad. I thought saving time was. Okay. Here it is, 3 meters, please. I know it's stop and go, but 3 meters. That's the height. That's you jumping up at what velocity?
5 meters.
All right, what's this? The idea is that the kinetic energy plus the potential energy at the top should be equal to The kinetic plus potential at the bottom, isn't it? So first I found the kinetic energy plus the potential energy at the top. What's the formula for kinetic energy? 1/2 times mass times velocity squared. Isn't that what I put? 1/2 times 65 times 5 squared plus, what's the formula for potential energy? mgh, 65 times 9.8 times 3. Okay? So I got the total energy at the top, which I got as 812.5 plus 1,911. Add them up, I got the total energy as 2724. Did that make sense? Okay, so I find the kinetic energy plus the potential energy at the bottom. The same formulas, 1/2 times the mass, which is 65, times the velocity squared, which we're trying to find. Because that's the question, isn't it?
Yeah.
Okay, so we do not know the velocity. Plus, why did I put 0? Because h is equal to what? 0. At the bottom, what is h? H is 0 because you measure height from the bottom. So I get it as 32.5 v squared. That's 65 by 2. That's velocity squared. Total energy is equal. That's a very important thing. So you put that equal to what you got before. Total energy at the top is equal to the total energy at the bottom, isn't it? And then it's just math. Divide this by this, you get that number, 83.82. Is that the answer? No, you got to take the square root. You know what? Even if you are not able to write everything really fast, doesn't matter. Why? It's going to be posted today. Before you reach home, it will be posted. No, that was 4. Let's do this together, guys. 3b. What do you have to find? The trampoline behaves like a spring. Behaves like a spring. There you have. So all the kinetic energy at the bottom will be transferred to the trampoline. So the formula now would be 1/2. Come on. Mass times velocity squared is equal to anybody. 1/2 what? Yeah, somebody said it. Tiffany. K times delta x squared, isn't it? Yes. That's all you do. And what do you got to find? How far does it depress it? What is that? Delta x. Can I cancel the halves? Okay, cancel the halves. Make delta x squared the subject. Delta x squared is equal to mv squared by k. Come on. Is that correct?
Yes.
And then substitute the numbers. What's the mass? It's 65. 65 times, what did we get the velocity as? I need your help because 9.15?
Yes.
Okay. 9.15 square root divided by what's the spring constant?
6.2 times
6.2 times 10 to the 4, which is 3 zeros, isn't it? Correct? All right, put this into your calculator and please tell me the number. So this is where you get the answer as delta x is 0.296 meter. Everybody take a look. Stop please. Number 4. Projectile is fired at an angle 45 degrees, right? I don't care because I just need to think about energy, right? And again the idea is kinetic energy at the top. What's the formula for kinetic energy? 1/2 mv squared. And that's 1/2 times, is the mass given? No, we don't need it. It'll cancel out. So keep it as unknown 185 squared. What's the potential energy at the top? What's the potential energy at the top? MGH. See, this time I broke it up into two parts. MGH, M times 9.8 times, what's the height? 265 meter. So if I add them up, wouldn't I get the total energy? Yeah. So kinetic energy at the top and potential energy at the top, add them up, I get the total energy. Which is, I took, you see, because the mass is common for both, isn't it? Just took it out. And so I'll have 185 squared by 2 plus 265 times 9.8. Now, total energy at the top should be equal to the total energy at the bottom. I've been saying that 10 times now. So now I decided to do it in one step. Total energy at the bottom. Basically because I thought there's less space, you see. So it's equal to, I'm going to put both together. Hey, what's the potential energy at the bottom?
0.
Why? Why is it 0? Because the height is 0. That's why there's only... Are you with me? At the bottom? Okay. So equate both. And what happens to the mass? Cancels out. Cancel out the mass. And then that's a lot of calculation that you have to do. Square this. I hope I put the correct numbers. Plus this times this. I added everything. I got that. And take the square root. Did you get 140.4 meter per second? Is that what you got? That is really big. That number is really big. What did you get?
I got 198.
Oh, that's even bigger.
That's 72.
How much? 72? It's coming up there. It has to go. I'm just showing you all the corrections that I made at the end, right? Okay. Number 5. What kind of energy do you give a spring? What's the formula?
Half K.
Delta x squared. And when that whatever flies off, what kind of energy does it have?
Kinetic energy.
Kinetic energy. So you're going to say whatever energy the spring had becomes kinetic energy, isn't it? Cancel the halves. You're asked to find the velocity, so make that the subject. Plug in the numbers. How difficult can this be? K is 950. And you compressed it by 0.150 squared divided by mass is 0.3. 71.25. Check the calculation again, please, because I'm just doing it. Okay. And you take the square root of 71.25 or 71.3 and you get 8.44 meter per second. Is that what you got?
Yes.
Good. In the B part, it says how high will it go? So what kind of energy is it going to have when it goes up? Potential energy. So what do you do now? The kinetic energy is going to get converted into potential. You see that? So you say 1/2 mv squared is mgh. Cancel the masses. You have to find the height. V squared by 2g, which is 8.44 squared divided by 2 times 9.8. Which gives you 3.634 meter. What's the... Okay, this guy is going up a 7.8 degree thing. It's 150 meters in height, isn't it? And you're asked to find the work. Work against gravity. What's the formula? MGH. MGH, all you got to do is 75 times 9.8 times 150 and you get the answer. Now, the B part, danger. You may not understand, but listen very carefully and you will. I spent a lot of time trying to say, how can I do it, explain it. So I spent some time. So please, when we get to that. The B part says, what do you have to find? The force that you apply when you on the pedals, isn't it? Okay. Isn't this the basic formula? Work is force times displacement. So to find the force, you have to have work divided by delta x. And I suggest you don't write because I leave it on the screen. Try to understand. You can't do both together. Now, I went back and said, let me find the work. Work prime. What is that? Why did I call it the work prime? See, if you read that question, you see that it says if each complete revolution of the pedals moves the bike, how many meters?
5.1.
So do you have to consider the whole work?
No.
No. You only consider the work done for 5.1 meter. So I took it as a ratio. I said 150 divided by 5.1. Where did I get those from? Where did I get the 150 from? Look, 150 meters is the actual height that he must go. And for that, the work done was 110300, isn't it?
Yes.
So I just put it up as a ratio and said, if that's the height, that's the work, then for this distance, the work would be, I hope you understood that. Did you?
Yes.
And working it as a ratio problem, I got that. So take it down up to that. So now I go, watch. I put that down there and say delta x. I stopped and said, but I don't know delta x, do I? And then I have to find delta x. What's the formula for circumference? 2 pi r. So I go 2 times 3.14 times, what's the radius? Isn't it?
0.18 meters.
Yes, because it's 18 centimeter, 0.18 meter, and I find out, I forgot to write that. Anyway, I got it as 1.13. I think I forgot to write that down there. And then when I divide that by 1.13, I get 3319 Newton. Somebody check this out, please.
Why did you do 0.18?
Change its meter.
Change it into meter.
Okay. 3319.
Is that correct?
Yes.
All right. Where is it? Blank? Okay. MGH, isn't it? What kind of energy does the baseball have when it's at the top? Potential, MGH, and as it drops, changes into kinetic. So MGH is 1/2 mv squared. By now, I think you should have got that. Okay, so you get velocity squared is 2 times 9.8 times the height, which is 13. And then that gives you 254.8. Take the square root of that, and you get?
15.96.
All right, 15.96 meter per second. So that part was easy. Now the B part. Now for the B part, let's stop. I paused it. Wait. For the B part, it's if it actually hits the ground with a speed of how much?
80 meters per second.
Instead of 15.96. So it lost energy, didn't it? So can we find the loss of energy?
Yes.
Yes, we can. How do you find the loss of energy?
Subtract 8 from that number.
Subtract 8 from this number? No, that will not give you the loss of energy. So you'll have to go back and find the initial kinetic energy, find the energy, kinetic energy. Now take the difference. This is what I'm doing. Watch. Kinetic energy at the bottom. If there was no friction, you would have got 1/2 times. You notice that the mass is given in grams. So you got to change it into kilograms. So 145 grams will become, well, that's supposed to be 0.145. 0.145 times 8 squared. You get 4.64 joules now, if there is friction, isn't it? Okay. Now I go back to what was the potential energy at the top? MGH? Okay. Plug in the numbers. 0.14 times 145 times 9.8 times 13. That was the original energy at the top, isn't it? So at that you get 8.47, 18.47 joules. That makes sense?
Yes.
So now can you find out how much it lost? Subtract. Okay. So you find out the energy lost, which is,
13.
let's see. Okay. I have to write everything the long way. 18.67 minus 4.64. This gives you what?
Wait, what?
How did you get 18.67?
Yeah, because when I went from one slide to the other, I forgot the number.
Okay, just making sure.
That makes sense?
Yep, just making
Did you understand? Because I had to keep it in my mind. And then when I went to the other slide, I put something else. Okay. What was the... I'm sorry.
18.47.
What was it actually? 18.47.
47.
Oh my. Ah.
Minus 4.64.
And what did you get? What was the answer you got?
13.83.
I still have the eraser. 13 point.
83.
Huh. Can't even write now. Okay, I managed to write 13.83. Okay. And now again. So therefore the work done by friction or work done by air was that much, isn't it? 13.3? Hey, why did we lose energy? Because of the air. So air did that much work, isn't it? Well, I'm working with my original number, of course. Please forgive me for that. So you correct and put it as 13.83. Go ahead, finish it. I'll let it run and then I'll change the number, okay? So where I've written 14.03, please write 13.83 and finish it.
It's number 8, not over this chapter.
Which one?
Number 8.
It's over this
Oh,
chapter.
not this chapter, what we went over today.
We went over that today. It's only that it's getting a little bit more tougher.
1.06.
Where?
1.06.
Oh, so that's the difference?
Sweet.
That's why I said I remembered 1 point. That itself was a miracle that I could remember that number, 1 point. My memory is real bad. This. Take a look at this. Try to understand as best as you can. All right. 18 degrees, 12.2 meter up the incline, and the skier, the skier is moving at what? 12 meter per second? Okay. So I first find his kinetic energy. What's the formula?
Okay.
Mass times velocity squared. And is the mass given? No. So we have to just leave it as unknown. But put the number that's given. That is 12 squared is 144. 12 times 12, isn't it? So that's where. So 144 divided by 2 gives you 72 meters. Then I find the potential energy at the top. And the formula for potential energy is mgh. And then I stop and I say I did not find the height. Look how I went back. How do you find the height?
Cosine 18.
I believe you should try to understand rather than write. H is,
Yes.
I have to take the sine because that's the opposite side, isn't it? Sine 18 would be this. So 12.2 times sine 18 and I get the height. I come back and plug in that height. And I get the potential energy as that much. Okay, now I'll give you time to write. So I find the loss. I get 72 minus 36, which is 35. And I know that the loss of energy is due to friction, isn't it? So I go work, just like before, work done by friction. Now I'm talking about work done by friction. F times del X. And I go 35 M, that's the loss, that's the work done by friction, is frictional force times 12.2, and I stop there. Because you see, I have to go to the next slide. See? I didn't want to remember all this, take it to the next slide, this number will change to I don't know what. So, First you find the height using h is equal to 140 sine 32. Sine 32, and that you told me is 74.2, isn't it? So that's 74.2 meter. And what's the formula for power? Work over time. And the work in this case is mgh, because they are lifting themselves up, giving themselves potential energy. So mgh by t. Plug in all the numbers. 95 times 9.8 times 74.2 divided by 66 seconds, and you have your answer. 1047 watts. Okay, go on to the last one. Well, you know what that means, 7 degree. And first I thought, let me find the height. Okay, you see what I'm trying to do. Like before, let me find the height, like you might be thinking. And then you end up with, but we do not know that distance either, do we?
No.
So I say, okay, I can't do that, two unknowns. So I go, what do you have to find? Power. What's power? Work over time. Work is force times displacement, isn't it? Hey, don't miss this. What's displacement over time?
That is
Velocity. So I got a new formula for power. Power is force times velocity. Slow down. Okay. And you know that the force you have to apply is mg sine theta. Anybody knows that? When you go uphill, the force that you apply is mg sine theta, because when you break it up into two components, you get mg sine theta and mg cos. We did that so many times. So that's the force you apply and the velocity. Problem done. Yeah, because mg sine theta. What's mass is 75, I hope. Is it? 9.8. That's the velocity at which he has to go up. Sine 7 degree times 5. Okay, that gives me 320.3. Problem done. Thank you. You have a good night.